Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhanim binti JOHARI. Matrix number 1191447. Thank you to my lecturer is Dr. Firdaus to give the individual assignment in problem-based learning. So in my title of problem-based learning is about astronomy, develop the equatorial and topocentric coordinate systems and how it facilitates astronomers and armatures to locate an object in the sky. So let's go. How and why the astronomer developed the equatorial and topocentric system. So, next, the contents of problem-based learning, we can see about the introduction of equatorial and topocentric coordinate systems, and then we go about research problem in the equatorial and topocentric and how the astronomer developed and how he used the both of a system. Third is about discussion and finding. So in their points is really to opening about the equatorial topocentric coordinate system and how astronomers use their system. And the last thing is about conclusion and recommendation and what I can give the recommendation in their problem-based learning. In the introduction we will cover about the equatorial coordinate system and then topocentric coordinate system. So in the equatorial coordinate system, we will feel about the declination and then the right insertion, how we will use with the equatorial coordinate system. So in the topocentric coordinate system, we'll be story about the how topocentric coordinate system will be related to the geocentric coordinate system. Next is that's a concept of geocentric coordinate system. So let me tell you about the equatorial coordinate system and the topocentric coordinate system. Next, let me learn about the research problem in my problem listening. So first, we can acknowledge the equatorial coordinate system and then acknowledge the topocentric coordinate system and both of them how we can use the equatorial and topocentric coordinate system from the astronomer. And lastly, how astronomer takes its system to locate of object in the sky. So from their system, we can know how the astronomer make the facilities to locate of object in the sky. So I will continue. So equatorial coordinate system, what is it? The coordinate system is which the certain object's position on the celestial sphere is described in the term of the declination and the right assertion, meaning a measure with the respect to selected equator. As a project outwards onto the stratosphere, the declination in the right section is correspond to geographic latitudes and longitudes. So in diagram, we can see how the equatorial coordinate system can be used in their diagram. So we can see the Earth has an equatorial coordinate system, and then with a rotation it leads to the Earth. Means that declination is a latitude of the equatorial coordinate system. Yes, so this is become the first session. You can see in the graph is a summer solstice, in the autumnal equinox, winter solstice, and the vernal equinox. That we know the equatorial coordinate system used to location of object in the sky is using declination in the right assertion. The declination in the right assertion are coordinates similar to latitude and longitude, but instead in the indicating equation of the Earth. They indicate the position of the end object in the sky, such as a star, and the equatorial coordinate system is known as the celestial coordinate system. It is used to determine the location of a selected object in relation of the Earth equator. It's based on indefinitely projecting to Earth equator into the space. So, declination is measured in the degrees, minutes, and seconds. And the right assertion also will be the measure in the hour, minutes, and second. So, about the topocentric coordinate system, we need the system on more astronomy to use the system because we can know based on the surface of the Earth. It is a relative of a geocentric coordinate system. So, the topocentric coordinate system from a local tangent plane to the Earth's ellipsoidal are expressed in the firm whose exits and not exit spiral surface which to a specific location. The topocentric origin to the exit points upwards along the normal to that plane. So in diagram, we can see the position of the topocentric coordinate system is related to geocentric coordinate system because there is a geocentric coordinate system whose meanings make the Earth as a point, means that all the planets, all the sun and moon would rotation of the Earth. So there is a position of a topocentric coordinate system. Means that exists with and its and slopes, meaning that is 19 degree for the position. So we can see that the position of the topocentric coordinate system. So this part, how its facilities astronomy in emeritus to locate an object in the sky. To explain an object's position in the sky, imagine the Langer's curve passing through the lattice poles and the object, which you might refer to as the object on the curve. The vernal equinox is a line where the sun crosses the celestial equator, which year around March 21. And indeed is the line that is used to calculate the object its two-way coordinates. Objects in the solar system, such as a planet, and from our perspective, the sun, the move across the celestial sphere rather than along the equators, because the Earth is inclined 23.5 degrees into the plane of the Earth's orbit around the Sun. Instead, the orbit is their own orbits. The majority which we are almost parallel to the Earth's orbit. The aesthetic or imaginary parts of the Sun appear positioned in the curve. So, like I see, this scarf line that always around the sphere from 23.5 north to 23.5 south. The zodiac position are all locations on the ecliptic. Declination refers to an object vibration above the celestial equator. In the conclusion, that I can conclude the equatorial coordinate system and the topocentric coordinate system is still relevant to use until now. And problem-based learning can always help others and me to link of learning gains new knowledge about this system. That's meaning that the equatorial coordinate system and then the topocentric coordinate system, and then I knew the position of Earth using the system developed by astronomy earlier. Means that the system the system earlier have developed by astronomy. So until now, this is a good position to astronomer and anyone to learn about the equatorial coordinate system and the topocentric coordinate system. So problem-based learning can develop the critical thinking skill and then problem solving, the abilities, and then how to look out the good thing in the problem-based learning. So for the recommendation of the problem-based learning in the title, this maybe they change the time always move forward. So the astronomical system such as the equatorial coordinate system and the topocentric coordinate system will be changing time by time, because the technology was being moved forward, and then have the others ways and others ways to know about the position of the Earth, of the Sun, and how to another technology can be location of object in the sky. So that's all from me. Thank you for listening my presentation.